All right, so we're going to have a mini lesson here on how to write an equation of lines that are parallel to or perpendicular to a given line. Now here I've graphed for you an orange line, I'll call it L, purple line I'm calling it N, and this black line I'm calling it M. Okay. So we're looking at these lines, and looking at them just by a quick glance, it looks like M and L may be parallel, and N may be perpendicular to both L and M. We could use our magic corner test. I'll take an old photo of myself from years ago. I take the corner and I put it in there, and it looks like that's pretty close to a perfect match. Okay, a picture of me from a long time ago, long before you were born. That was in the 90s. When I worked in Petaluma. So we look at this and we want to figure out what the slope is of this line. Now we could say, let's take 2 points and get their coordinates. This would be the point 1, 2, 2, comma 2. And this would be the point 1, 2, 3, 3, comma 0. And we could use the idea that the slope is the change in your positive direction, your y direction, vertical direction, versus over the change in your horizontal direction. 2 minus 0 will tell us how much vertical we changed, and 2 minus 3 will tell us how much horizontal we changed. 2 minus 3, which gives us a slope of 2 over -1, or a slope of -2. We could have just looked at it and said, oh, well, from this point to this point, I got to go down 2 and to the right 1, down 2 and to the right 1, so I'll make a -2 over 1, which is still -2. Okay? Down 2 and to the right 1. We could look at this one, we say the same thing. We can go from this point, you see the orange dot, to this point, down 2 and to the right 1. So it has the same slope. M equals down 2 and to the right 1. The same slope. Therefore, M is parallel to L. Okay. These bars mean is parallel to. And we look at the line N. I used my little magic corner on my photo from 25 years ago, and you could see that this looked like it. So let's look at our points. So we got a point here, 2, 2. We got another point, 4, 3. And we get to 3 minus 2, that's a 3, I'll write it down, I'll write it up here. 3 minus 2, that's our top of our fraction, 3 minus 2, and then 4 minus 2 is our bottom, which equals 1 over 2. Okay? Or we could have just said, I'm going up 1 and to the right 2, up 1 and to the right 2, up 1 and to the right 2. And that's my slope, up 1 and to the right 2. 1 over 2. And we look at this slope, this is 2 over -1. So these two slopes are, yes, negative reciprocals, so that L is perpendicular to N. And M is also perpendicular to L. Okay. Should have put the L there to make it more consistent. Well, let me just do that. L is perpendicular to M. L is perpendicular to N, and golly, N, and M is perpendicular to N. M is perpendicular to N, and L is perpendicular to N. Since L and M are parallel, they're both perpendicular to that same line. Now, what if we wanted to write an equation of a line parallel to both M and L? The first thing we need to know is that if it's parallel, then its slope has to be the same. Okay, so we can automatically go y equals -2x. Okay, then we just have to pick a point for it to cross. Let's say it crosses here at +1, and then we'd have our line. Dun, 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 dun. And we could draw in another parallel line. Okay. And what if we wanted to line perpendicular to this? Well, perpendicular to a slope of -2. Okay, so we need a slope of 1/2. So our equation could be y equals 1/2 x plus whatever number we like, as long as it's not the same number that we have here. This is a +1, so we can do +2, +3, +4, plus -1, plus -2, plus -3, doesn't matter. I'll do -3. Okay. 1/2 x plus -3, that tells us 1, 2, 3. It's going to cross there. And a line perpendicular to M will also be parallel to N, okay, because it has the same slope. And that's how you write the equation of a line given that you're looking for parallel or perpendicular.